it's the integration of 1 over sine plus cosine. So this integral is quite hard in many ways. It needs so many different things to solve it. But here I'm gonna some equal errors so you guys kind of see what I'm going to. So the way to solve this integral, first we are going to take, well, partial fraction. So we're going to take our 1 for cosine 4x. So we're going to take that and just put it on the top. So let's make it a complex fraction. That's a 1, not a 2, remember. My writing is just really sloppy. There we go. And then we're going to put this over, what will the fraction be? It'll be sine to the 4th x. I will have a partial fraction video going up at some point because a lot of this can be really confusing and there's a ton of steps for partial fraction. We're just going to put sine 4x over cosine 4x and then plus cosine 4x over sine 4x. I'm saying 4, but I just mean like the exponent. There we go. Oh man, this is rough. Why is it doing this? Okay. So I gotta just get this thing, bro. There we go. That's actually really useful. Okay. So using partial fractions, this integral will turn into this problem. We can simplify this with substitution. So what am I going to do for this? I'm going to do 1 over cosine to the 4th x. And we're going to make this also a complex fraction. Remember, we're going to have sine 4th. We're just going to make cosine of the 4th x over sine of the 4th x a 1. Put a cosine 4th x here. Now, let me explain something over here. So we have sine x over cosine x equals tan x. I can put a comma here. See if I could I'm trying to drag it. There we go. So equals tan x. Now with partial fraction we have to actually give an explanation of what we're subbing out for. So what we're subbing out for is just our cosine x equals, remember the derivative of tan x sec x. Okay. So now that this part of the integral is done, I can go to the next step. Not even close to done either. This is a really long process. So remember our substitution, we have sine x over cosine x equals tan x. And then we had, if I go back, we had 1 over cosine x equals sec x. So that's what we're going to use for our substitution. So remember, we still have our 4 there. So here's sec to the 4th. X over tan the 4th x. Remember our plus 1, because we have that from our equation back there, and dx. Now, I'm going to make another proof. We have our, let's try to simplify our problems. Let's do sec squared x equals 1 plus tan x. Okay, well, tan squared. Do not forget the squared. Okay. Now, we go into the next part. Let's write what we're doing in this step. Integration by sub. That's super messy, but does not matter. So what are we gonna do for this? We're gonna do substitution. I already made a U-sub video on basic integrals. This is gonna be pretty similar. We're just gonna have U equals our tan x, because that's the worst part of this problem, most annoying part. Now we're gonna find our du. Remember, derivative of tan, we're gonna get sec. So du equals, what would it be? Du equals sec squared x. Don't forget the dx. Remember from my last video, never forget the dx when working with partial derivatives. We can erase this, it's too messy to work with. There we go. Now, wow, this is already super overwhelming. I don't know if you guys are cool with the amount. Oh, should I add the vertical part? Okay, cool. So now it's actually u sub. So this equation we are going to have, let's write our original integral. Now just using our sub as well. So 1 tan, or actually I have to write 1 plus tan. One plus tan squared x. Sec squared x. The dx. This is a fraction though. And then we still have from before our tan x plus 1. So, off of just using substitution, we now have this integral. So, let's move this again. Now we can plug in our u value. This part really shouldn't be too bad for the people that watched my U-sub video. So we have a 1 plus, remember we used tan squared, so make that our u squared. Put this over our now u to the 4th. Oh, I forgot to write the 4 over here. That could have messed you guys up. U to the 4th plus 1. Ooh. Now this integral, we can, what can we do here? What we can do is we could simplify our denominator, or we can factor it. That would make this equation much easier to solve. So let's do 1 u squared. Let's leave that on top. Then the bottom, we'll do factor this out. It should be u to the second plus u square root of 2 plus 1. That should be it. And we also need the conjugate. So u squared, except at this time minus u square root 2 plus 1. And don't forget the du. Ooh. Okay, now I'm just going to write, I just want to make sure you guys know how partial fraction works. I did make a video on this. Partial fraction, we have our, I'm going to do it in terms of u, considering we're using u sub. So au plus b over our u squared plus u square root 2 plus 1, and this is going to be plus our cu plus a d over our conjugate squared. Needs to be a minus u square root 2 plus 1. Ooh, if I'm right, subbing this in is going to be a very, very long equation, but gotta do it. Okay, I'll sub this value in. So, let's see. Remember, in terms of u, so au plus b times our u squared minus u square root 2 plus 1 plus our, we could do it opposite, but it doesn't matter. So parentheses c u plus d. I guess it would be better if I did it the other way, but I'm not changing it now. So now u squared plus our u square root 2 plus 1. That should be the whole top fraction. There we go. And now we still have our, from before, remember, we still have our denominator here, so we're still going to keep that. Let me just write it out. U squared plus u root 2 plus 1. And we have our other one. We have u squared minus u square root 2 plus 1. There we go. Now, this is going to turn into a mess of a fraction. If we're going to do this as the most simplified way possible, which will help us solve our equation, we're going to need a lot. So, u to the third plus our, or times our a plus c. If you guys remember my partial fraction video, I kind of explained how this works. U squared Which plus that plus u squared multiplied by our negative a square root 2 plus b plus c square root 2. Oh, let me see how all of this is working. We have a 2 plus b plus c square root 2. Remember our plus 1 from before. That's kind of what I was worried about there. I was worried if I forgot that plus 1. But this is going to be plus our normal u now. So we got our u cubed, we got our u squared, now we got to get our u. Put this over here. So this is now going to be a minus b. A minus b square root 2 plus c plus d. Man. C square root 2 plus b plus d. That should be the whole top row. I know it is a lot to work with, but it is the only way to solve this. So, alright, yeah, you could do this integral in different ways, but like this is probably the easiest way to solve this. Let me just draw an entire line under our numerator. How to move the whole screen just to write the line. But that is our numerator right there. Now remember, we still have our denominator from before. So u squared plus u square root 2 plus 1. We still have our u squared minus u square root 2 plus 1. There we go. Now I'm moving to go even farther down on this board. Oh. So now I'm going to write our values here. So this is going to be our key that we're going to use to solve the rest of this integral. A plus c equals 0, which means that negative a square root 2 plus b plus c square root 2 plus d is going to equal our 1 value. There's still another 0 value in this though. Our 0 value has to be our a minus b square root 2. You're going to notice a lot of patterns in this. C plus d square root 2. That's going to be our next 0 value. So, if you notice, since this is negative, we're going to have a negative a square root 2 plus b c square root 2 plus d. But in the other one, we're going to have our, if we're making our positive, we just have a alone minus b square root 2 instead of positive b. So we're just taking the square root 2 and putting on every other value and also swapping the signs along the way. And that's why 1 equals 1, 1 equals 0. And now we still have our b plus d equals 0. There we go. So with just this, we can change our entire integral. Now we have the integral to u. I believe it's 2u plus 1 over 2. Now we have our u squared plus our u square root 2 plus 1. Don't forget that. So now we're like really in partial fraction here, like just like the very like default form. So now, but obviously it is in terms of u though. D over u squared, u square root 2. And now we have, actually no, whoa, almost forgot. This is the conjugate, so u minus square root 2 plus 1, that should be it. Don't forget the du. So let me turn this integral into a whole different problem. So if we're gonna factor this out like we do partial fraction, we're gonna have to factor this 2u, because that's gonna be a problem for us. So we could turn this whole thing into the integral two squared plus u squared 2 plus 1. We're keeping that denominator. Never forget that denominator. Plus 1 over 2. And we have our conjugate. U squared minus u square root 2 plus 1 du. Here we go. Now, turn this whole problem. We have the 1/2 there. Gonna make this the integral 1/2. A lot of this is just pattern recognition. Like if you know that we're just keeping like the same denominator the whole way through, then a lot of the other steps kind of come easier. Go down. Ooh, okay. Now when I did solve this problem, that was the majority of this integral. It does get a lot easier from here. It took me like a half hour to actually solve this integral. But I did get the right answer, so now we're actually integrating this. So that's why we're gonna actually have u square root 2 like before, except over 2 because power rule. Plus 1/2 plus our 1/2 from before. You guys remember those two 1/2s that were in our numerator and then now in our denominator. And don't forget the du. Now we're going to change this integral into one-half. Still keep our u plus 1 square root 2. This is also just power rule properties, because we're going to put this whole thing in terms of squared plus our 1/2. Because if you guys see we have square root 2 over 2, we can just make that 1 over square root 2 squared. Let me. So now we can go another arrow. Now we're going to do another integration by substitution. Oh man, writing is just not my strong suit today, man. Oof. So integration by sub, what we're gonna do here is our what we're gonna do here, we already used u. Our next value has to be t. So we're gonna use 1/t equals u 1/2. Actually we can't use 1/2. I am lying. Ooh, man, this is one complicated integral, man. U 1/√2. And this is going to equal our dt instead of our du. So we're using our dt, although this whole thing does equal du, we're going to incorporate our dt. So this is a little bit more in-depth of substitution that I haven't taught on the channel. But hopefully you guys can kind of keep up on what we're doing here. So now we're going to make this whole integral of √2. Let's see, u. Can't forget this part. 1/√2 t equals u 1/√2. Still substitution. Now we're going to make this (1/√2) dt equals du. So remember, we're just filling in the values. We already had that entire equation dedicated to knowing what du is. So remember, we had this. Now we're moving into this using our actual values. Ooh. Now let's put it back into an integral format. So if we're putting it back into our integral format, we're going to have our 1/2 still. Still have the 1/2. Now we still have our 1/√2. Now we're going to use our t value. Remember our square from before that we got from our power rule. Plus 1/2. Now we're going to make this whole integral 1/√2 dt. Because we used our du value, so now it's 1/√2. I'm not clicking down. I don't know why the mouse did that. Now let's go all the way back. Why is it doing this? Alright. So now we are going to change our integral again. So now we're actually going to integrate it. So we're going to keep the 1/2 as our numerator, except our denominator. We're just going to have 1/2 t squared. Because remember what we had our t subbed out for, it was 1/2. So now we're just going to have t plus 1/2 from before. And we still have our 1/√2 dt. Now let's move this again. We have the integral 1 over just our t squared plus 1 didn't mean to write the d there, square root 2 dt. This also has to move. Now we're going to use our trig identities. 1 over square root 2. This is just going to be arctan. Arctan. Oh wait, actually we're doing it in terms of t. My bad. Arctan t plus c, because now our integration constant's alone, so we can just get that plus t in here already. Or we got our dt alone, so now we got plus c. Okay, that's how you know we're getting close to solving this integral. Finally got that plus c in here. So now that we're using trig identities, it's going to be a little bit more complicated in some aspects, but we still have our original integral. 1 over 2 over 1 over 2 t squared from 4 plus 1 over 2. Now we have our 1 over square root 2 dt. This is going to turn into make sure I'm doing all of this right. I think I'm looking at the wrong thing. Yeah, this does equal what I'm thinking it equals. Huh. So we do have the integral there. You know what? Let's start from scratch here. We have our arctan plus c. So I'm going to keep the plus c. I don't know what I was thinking. Plus, we do already have our 1 square root 2. And since we're using our trig identities, let's keep our arctan. Arctan in terms of u 2 plus 1 plus c. Whew. Now we have the integral 1 over 2 over u squared plus u square root 2 plus 1 du. So now we're subbing out our t back into our u. And now we have our 1 over 2 u squared plus u 2 square root 2 over 2 plus our 2 1/2. And now it's in terms of du and not dt. Alright. Let's go down even more vertical here. So now we are working with 1 over square root 2 arctan u I don't know what I'm struggling so much to write very simple things. U square root 2 plus 1 plus our 1 over square root 2 arctan. I keep ending this parenthesis, but it is actually just the our normal denominator and then the conjugate. It's actually like not that crazy. I don't know why I'm messing up the way I'm messing up. And now we have our u square root 2 minus 1 instead of plus 1 and plus c. Now, our last step to solving this integral is just taking the u out for what we subbed it out for. So, 1 over square root 2 arc tan, and we subbed it out for square root 2 tan x plus 1 plus our 1 over square root 2 arctan. And then just where we subbed out u4 again. X this time minus 1 and plus c. That is the solution to our integral. No further simplification is needed. Oh man. This one's definitely the hardest one I've done. It's also the hardest one I've ever done myself.